Right. These are a series of replacements. You want to take what's there and replace it with something equivalent in the hopes that something will cancel. That's what simplifying is. You want something to cancel out so that it'll be more simple than it was before. So when in doubt, if you're not sure, change everything to sines and cosines. So looking at this first one, I already have a cosine there. I'm just going to leave it cosine theta, but I would maybe put it over 1. Sometimes that helps whenever you have it as a fraction. I don't know, personal preference. What can we replace cotangent with? Good, that would be cosine over sine. Now, when you divide by a fraction, you multiply by what? The reciprocal. So I'm going to flip that over. So we would have cosine over 1, if you would like to put that over 1. Again, I think it's not a bad idea. Change it to multiplication, and we're going to flip this over so that we have the reciprocal. Again, the goal is for something to cancel. That's what simplifying is make it look more simple. So what's going to cancel out? The cosines cancel. You have sine over 1, which is just sine. So that's your answer. That's the work. You do the replacements and show me what cancels out. All right, for this one, see how it's this whole thing squared? That means you need to write it twice. And it's going to be FOIL. First, outside, inside, last. We have done this before. It's just got a sign in it. You can't let that part bother you, okay? It's first, outside, inside, last. Here we go. 1 times 1, 1. The outsides give you 1 sine of theta. The insides give you 1 sine of theta. So altogether, that would be good. 1 plus 1 is 2. So 2 sine of theta. And then sine times sine. Good, sine squared of theta. And then minus sine squared of theta. That's this part at the end. Now, again, the idea with simplifying is you want something to go away, like something should cancel. So what's going to cancel? Yeah, those are gone. And so this is just your answer. When you see the 90 minus theta, those are the co-function identities. So you're going to add a co or remove a co. So since this is cosecant 90 minus theta, what is that part going to be? What do we replace that with? Good, that part's going to be secant of theta times, now this one's sine 90 minus theta. That will be cosine theta. So again, it's a series of replacements. We replace this with secant, we replace this with cosine. Now I'm going to do another replacement. What can I replace secant with? That's 1 over cosine times cosine. They cancel, and so what's your final answer to the whole thing? 1, which is kind of cool. All right, here again, when in doubt, you want to replace everything with sines and cosines. Let's do them one at a time. What are we going to replace cotangent with? Good, I'm going to replace that with cosine over sine. Now this part's just cosine, but again, sometimes I think it helps if you write that over 1. Again, personal preference. If you don't want to do that, then fine. And then that's all over cosecant. What can I replace cosecant with? That's 1 over sine. So I replaced everything with sines and cosines. Now the idea is that something should cancel. What's going to cancel there? The sines are going to cancel. You can pretty much ignore the 1s because dividing by 1 or multiplying by 1, nothing's going to change. So what you have left is cosine times cosine, which will equal what? Cosine squared is your final answer. Now, verify is actually a little bit nicer than simplify because here it's kind of like you just keep on going until you feel like you've got it as simple as you can. These are nice because the answer is actually on the paper. You start with the more complicated side and fiddle with it until you get it to equal the simpler side. So which is the more complicated side here, left or right? Left. Okay, we're going to start with this side, mess with it until we get it to equal negative sign. That's the answer. Like you already know the answer, you just have to get there. Now the ones with the negatives in, the odd ones turn negative, the even ones go positive. So since tangent is odd, what is this going to equal? What are we going to replace that with? Negative tangent times cosine. All right, now what can we replace? Again, it's a series of replacements. What can we replace tangent with? Good, sine over cosine, and the negative is gonna stay there. Then times cosine. And then what? Cosines cancel and you get negative sine of theta, which is the answer. So then you like know that you're right, but it's like what I'm grading is the work, like showing those replacements. Now this one, deciding which is the more complicated side is actually a bit tricky here. It's really this one, because you're trying to subtract those and combine them together. So we're going to start with this side. What can we replace cosecant with? 1 over sine, good. Minus, and then cotangent is cosine over sine. Now you would need to get a common denominator, except they already have one. Isn't that fantastic? They have a common denominator, so you just need to put them together. 1 minus cosine theta over sine of theta. And oh my gosh, guys, that's the answer. See that right there? All right, this one, this is definitely the more complicated side, the left side here. So let's look at the numerator. See that squared in there? We're going to use a Pythagorean identity. I wrote them on the board, so look up there. Cosecant squared minus 1. I'm looking at this one right here. If you have cosecant squared and you subtract that 1 over, what can you replace that with? Good. That numerator, we're going to replace that with cotangent squared. Now, when in doubt, you want to replace everything with sines and cosines. Cotangent is cosine over sine. It's just that it's squared. So I'm going to replace that with cosine squared over sine squared. There's just a squared in it. So it's cosine over sine, except there's a square. All right, and then what can we replace cosecant squared with? 1 over sine squared, because cosecant is 1 over sine. It's just that it's squared. And then we're nearly there. Now what's going to happen? The sines cancel. You have cosine squared over 1, which just is cosine squared. And that is your answer. You can see it printed on the paper. So again, these are the ones that you don't need to memorize. I'm going to give you this formula sheet. So we're going to draw a triangle for each of these. That's like your work, okay? What quadrant is 7 pi over 6 in? 3, good. Your reference angle is pi over 6. What goes across from that? Good. Other side, square root of 3 over 2, and they are both negative because we're in the third quadrant. Again, that picture is like your work. Pi over 3 is in the first quadrant. What goes across from the pi over 3? Good. And then other side is a half. They're both positive. So I'm going to pull up my formula sheet. This is sine, and we're adding. So I'm going to use this one right here, this very first one. So just read along with me. I'm going to point to it. All right, so sine of A. And if you want to label these, this is A and this is B. Sine of A. So looking at this triangle, what is sine? Good. It's the y value, so negative a half. Then we want cosine of B. So cosine would be the x value, that would be 1/2, plus cosine of A, that would be the negative square root of 3 over 2. And then sine of B would be square root of 3 over 2. So again, you just draw the triangles, follow along with the formula, and now we're going to sort through that. When you multiply fractions, you multiply the top, multiply the bottom. So when you multiply these together, you're going to get negative what? 1/4, good. And then this will be minus, because we have a negative there. Square root of 3 times square root of 3, what's that going to give us? Just 3, right? Because it'd be square root of 9, just 3. And then 2 times 2 is 4. Oh my gosh, they have a common denominator. That's going to happen. I know. Negative a fourth minus 3/4. That'll be negative 1. Perfect. All right, let's try it again. Pi over 4 is in the first quadrant. Both of the sides will be what? Perfect. And they're both positive. Now, this is not negative 2 pi over 3. That negative is just going to tell us which one of these formulas we want. Okay, it's a positive 2 pi over 3. That's in the second quadrant. This will be square root of 3 over 2. Down here is a half, but it's negative. So again, those triangles are your work. Now I'm going to figure out what formula I want. It's cosine and we're subtracting. So that's this one right here. All right, and if you want to label these, this is A and this is B. So cosine of A will be square root of 2 over 2. Cosine of B, negative a half. Plus sine of A is square root of 2 over 2. And then sine of B, square root of 3 over 2. So again, you draw the triangles, you just follow along with the formula. You don't have to memorize it. Now we're going to sort through this. When you multiply these first ones, you would get negative what? Good. Square root of 2 times 1 would just be square root of 2 over 4 plus, and then this one would be square root of 6. Good. 2 times 3 is 6 over 4. They have a common denominator. You just have to put them together. That's it. Your answer looks a mess. You just accept it and move on, right? This is going to be the double angle formula because it has a 2a in there. First, let's draw the triangle. We're in quadrant 3. And tangent of A is 7 over 24. We're back to SOHCAHTOA. It's opposite, adjacent, hypotenuse. It's not on the unit circle. So tangent is what over what? Good. So this is 7, this is 24. I made it one of the locker combination ones. What's the hypotenuse? 25. Now, because we're in the third quadrant, what's negative? Yeah, like both of these. So you just got to be careful with that. The reason this is positive is because the negatives canceled out. This is like your work. Now we're going to go and find the formula we want. It says cosine 2a. There's 3 different versions of that. It does not matter which one you use. I just always use the first one just because it's the first one and you have to pick one of them, all right? So we're going to do cosine squared. And so what is cosine using this triangle? Good. Negative 24 over 25. So cosine squared minus sine squared. And sine is opposite over hypotenuse, so negative 7 over 25. Now those are both negative, but when you square a negative, what happens? It's positive, okay? And on your quiz, I made it the 3, 4, 5 triangle. You'll be able to do it without a calculator, okay? But I changed the numbers for this one to make it different. So 24 squared, 576. Do you know 25 squared? Does anyone just happen to know that one? 625? Minus, and then this would be 49 over 625. So subtracting this, 527 over 625. Again, you won't need a calculator for your, so maybe numbers smaller. And then this last one is the half angle identity because it's A over 2. So again, let's draw the triangle. Quadrant 1. Tangent is 12/5. Tangent is opposite over adjacent. What's the hypotenuse going to be? 5, 12, 13. This is like your work. Now I'm going to pull up my formula sheet. These all say plus minus because it depends on what quadrant you're in. I'm going to put it in quadrant 1, so it'll be positive, so don't worry about that. And we want sine A over 2. So we're looking at this first one. So it is big old square root 1 minus cosine. So what is cosine using this triangle? Good, 5 over 13, and then that's all over 2. Now I would erase the 1. What can we replace the 1 with to make this like actually work out for us? Yeah, make that 13 thirteenths, because then you can put these together. 13 thirteenths minus 5 thirteenths would be 8 thirteenths over 2. And then if you divide by 13 and then divide by 2, you have really divided by 26. Now that answer can be simplified further, but frankly, I don't care. And I'm fine with you stopping there. Okay. Like Delta Math wouldn't take that answer, but Miss Cole will.